Good morning to our chief guest and resource person, Professor Kumar sir, HOD Mechanical NIT Warangal, and good morning to HOD or BVRIT Mechanical and convener of this program, Dr. Ramakrishna garu, and all the faculty members and participants who have all joined here for this inaugural session. On the behalf of Department of Mechanical Engineering, BVRIT Narsapur, we welcome you all. Myself, Dr. A. Varun, Associate Professor, Department of Mechanical Engineering, and the Program Coordinator. And this is an AACT sponsored 1 week short-term training program on design of experiments in engineering. And today it starts day 1, 16th of November to 21st of November. And we have 2 sessions planned for forenoon at 10 a.m. to 12 p.m. And afternoon session starts from 1:30 p.m. to 3:30 p.m. So the main aim of this STTP is to introduce the participants, the training session on the statistical methods for designing, analyzing the experiments, and the topics are selected for the programmer to make use of these blended both theoretical and experimental hands-on practice. And these sessions are mainly intended both for the entry level beginners as well as for the experts, and the sessions are being handled by all the eminent professors from NITs and IITs. And as per the guidelines of AACT, 80% of attendance is mandatory with along with feedback, and 60% marks for the online quiz at the end is mandatory for awarding the e-certificate. And moving on, in the registrations, we have got 80 registrations, and we have 67 male and 13 female. And you can see the professional experiences of these faculty members who have registered, and they have covered the entire disciplines. Many of them are from mechanical, but this is can be applied for other branches also. So you can see this thing. And the registrations have been received by all other engineering colleges from various parts of India. So we have different participants from very good institutions, premium institutions as well. And the expertise also, it is covering wide range, like very low or no idea on the DOE to expertise are also categorized here. And the sessions are planned in this way. So we have already covered the session planner, or shared this session planner with you. So you can all join the session planner as per these details. And now I request our HOD, Ramakrishna garu, to say a few words on the STTP.
Thank you, Dr. Varun. Good morning to Professor and HOD Kumar garu, and very good morning and welcome to the participants and dear colleagues, those who are participating in the inaugural function. First of all, I would like to express my sincere thanks to Professor Kumar garu for accepting our invitation and present in inaugural session. Once again, on behalf of the college and department, I am very much happy, sir, for participating in the inaugural function. And because it is an online program, so I will introduce the department briefly. The college is the BVRIT Institute of Technology. It is popularly known as BVRIT. Started in the year 1997. But the Department of Mechanical Engineering is started in the year 2009 with an intake of 60, but the present intake is 120, and the department has one MTech program in engineering design, and the department has expertise faculty in different fields of mechanical engineering, and faculty are from IITs, NITs, and reputed institutions. And the faculty members of the department have publications in journals like ASME, ASTM, elsewhere, Taylor and Francis, etc. And the department has some patents granted, and the department has state-of-art laboratory facilities and the department has very good collaboration with industries and R&D institutions to carry out the research work. And the department even doing some sponsored as well as consultancy projects in the mechanical engineering area as well as interdisciplinary area. And the specialty of the mechanical department BVRIT is here many core companies visiting the campus for recruitment of the students. The students got placements in Thermax Limited, Saint, SKF Bearings, Rane Holdings, Hyundai Motors, and Renault Nissan, FMC, Sanmar, even Tata Engineering, okay, and Fest Global. In addition to the placements in software companies like TCS, Tech Mahindra, NTT Data, HTC Global, Urjanet, etc. And I congratulate Dr. Varun for getting the funding for this STPP on design of experiments in engineering. And it is a actually this type of the design of experiments helps in interpretation of experimental data. Definitely, it is a systematic method to determine the relationship between the factors affecting output of the process. And I thank Dr. Varun for planning hands-on sessions in this STTP, and even he identified good resource persons for this 1 week STTP program. And I once again I thank all the resource persons who accepted our invitation, and I and even Dr. Varun planned some case studies also in this program. And I thank other faculty, those who are involved in organizing this 1 week STTP program on design of experiments for engineers. And regarding this registrations, I think as Dr. Varun mentioned, 80 participants are registered across all the disciplines, and the registrations are from all the parts of the nation, including registrations from IITs and NITs. And I would like to thank our principal, sir, for encouraging, for organizing this one week STTP program, because sir actually agreed to address this, but because of what is that meeting with the IIT director at 10 o'clock, he will join later, and he asked me to convey the same to the participants. And I would like to thank our management for encouraging to organize this type of programs. And once again, I would like to thank Professor Kumar Garu for accepting our invitation. And I would like to thank Dr. Warren and his team for making what is that this for organizing this STTP again. Okay, and I what is that seen, because they identified very good resource persons from India as well as the abroad. And I hope the faculty who registered for this or who are participating in the STTP will definitely benefit from this program. And I advise the faculty to transfer this knowledge to the students so that they can do some good quality projects. And thank you so much.
Thank you, sir. Thank you for giving us the introduction to the department and college. And like you rightly said, this will help in transferring the raw data into useful experimental data. So this brief introduction of the speaker, as you can see, Kumar sir has done his PhD from Usmania University, and he has done it under the guidance of Sundarajan
Dr. Varun,
sir.
I request Professor Kumar gar, please on the video.
Yes, sir. Yes, sir.
Yeah. Good morning.
Good morning, sir. Yes, and now it's visible.
Very good morning, sir.
Yeah, good morning.
So, sir has done the PhD under the guidance of Dr. Sundarajan, sir, with whom we are closely associated with. He was former director of a Vedic platform, and it's very good to know that Sundarajan, sir, has as a guide. We have the eminent professor here. Kumar sir has done many research contributions for the BrahMos aerospace missile, and he has masters from production engineering from Sri Venkateshwara University, BTech from Kakatiya University, Kits Warangal, and he has a vast experience for 20 years of teaching and 16 years of research experience. And his areas of research includes additive manufacturing, friction stir welding, friction stir processing, modeling of the friction stir welding processes, fabrication of composites of by casting process, and electric discharge machining of titanium and superalloys. And he has guided 12 PhDs and 6 under progress. And sir has, to his credit, 95 highly reputed international journals and many conferences. And he has completed 4 projects worth of 50 lakhs, and many are ongoing. And he has filed 2 patents. And I personally know sir because during my PhD, sir has helped me to initially frame my objectives, because my area of research also was on electric discharge machining. And I remember still when I first met sir with a few objectives, he has corrected the objectives, and then we were able to frame it in a better manner. Thank you, sir. Thank you very much for accepting our invitation with a short notice and addressing as a chief guest in the first day of session. And I would request Kumar sir to say a few words about the session and then start the session. Thank you very much.
Yeah. Thank you, Dr. Varun. Respected principal, Dr. K. Lakshmi Prasad, BVRIT Narsapur, and Dr. V. Murali Krishna, Professor and Head Mechanical Engineering, and Dr. Varun, Coordinator of the AICT FDP program on Design of Experiments in Engineering. At the outset, I thanks to the convener and chairman and other faculty members to give me the opportunity to share my knowledge to this FDP program. So in fact, design of experiments can be used in any field of engineering, especially most of the scholars are working in experimental based work. So definitely this kind of techniques or tool can be used for minimizing the number of experiments as well as cost of the process. It has so many advantages. Even if you are using in a simulation kind of work also, you can use these kind of techniques so that you can reduce the time for simulation and other activities. Once I go through the schedule of the program, it is very nice and very informative to the participants, what I understand from the program coordinator. So he has planned very well, and he has taken the inputs from various speakers from NITs and IITs. I think most of them are related to my students. They're also expertise in the area. I'm very happy to see you, Varun, here.
Thank you, sir.
Conducting this type of program. In NIT also, we are conducted so many programs, a lot of response about this program. So you can continue for this every year or every in twice in a year. You can also conduct so that people can explore. People take the advantages of using this kind of tool to reduce the minimum cost of the experimentation. I'm surprising. The people are spending like 2 lakhs, 3 lakhs on experiments. Even they are in JNTU or Usmania. I'm surprising. So it is not necessary. Once you are planned according to your objectives, and you can use this kind of tools, then you can minimize the number of experiments. Finally, you are going to get the good number of publications. The good number of publication is one important aspect in your career. So this actually, in fact, I met Dr. Sundararajan during my PhD program. After registration, Sir has given this book to me, Taguti, Design of Experiments. You can read and come back after 15 days. Then I gone through the textbook. I'm not able to understand because in those days only few people are known to this tool. That is statistical methods in Hyderabad. The institute is there. Only few persons are there, but Sar is also a member in the statistical methods. Sir has learned many techniques, not only this particular techniques. So he has vast experience. I'm very thankful to him, be a guide for me. So, so after 15 days, I am not able to understand. Then I have discussed with one of my co-researcher. He is also not able to understand, and I went to sir, I am not able to understand. Then you can go read again. So like that, after 6 months, we are the expert in the particular subject. We have to teach the sir, in fact, to this some of the areas. Then I got 2 publications with these use techniques in materials and design. Now the impact factor is 5.6. I got 2 publication immediately within 1 year. I got 2 publication, and one is in International Advanced Manufacturing Research. Then I am ready to publish, submit the thesis. So in this way, people can be benefited. Learning things in a own way, it is more efficient than the teacher. What should I say? So with this, I can conclude my speech and the participants. I request the participants to actively participate in this 5 days program, and also Dr. Varun also arranged live sessions. You can practice. Then don't use MATLAB and other things. Just you can go with the Excel sheet. Then you can able to understand very easily. Only it is simple mathematics. There is no complicated mathematics here. So once you learn these inside the knowledge of what is happening, then you can able to understand very well about your process. Then you can apply your knowledge in your output of the results. So with this, I can conclude my speech, and I'll move on to my presentation with your permission. Yeah, Dr. Varun.
Yes, sir. Sure, sir. I'm just handing over the session to you, sir. I'll make you as the host so that you can pull up your PPT.
Can I share my PPT?
Yes, sir. Right now. I'm just removing mine. Yes, sir. Now you can.
Yeah. Are you able to see?
Yes, sir. Full screen will be better, sir.
Yeah. Yeah.
It's on.
Okay.
Yes, sir.
Yeah. I think total 80 participants. Many of them are maybe known to the Taguchi of design of experiment in somewhere else. Even then, you'll be perfect in the particular subject. Yeah. Yeah. Now, can I start, Varun?
Yes, sir. Yes, sir.
Yes, sir. Yeah. Yeah, Taguchi design of experiments, we can short form, we can call it as DOE. DOE is not a new technique. Once I go through the textbook of design of experiment by Taguchi, then after 6 months, I came to know that it is not a new technique. It is a old technique. It is a statistical techniques. Taguchi has done a lot of experiments on the machining of tiles, and based on his vast experience, he came out with some layouts. So those layouts are taken from the full factorial designs. So based on his vast experiments on machining of tiles, and he will be concluded these are the layout for particular parameters of the particular levels. So we can say it is a fractional factorial design of experiments. Fractional factorial design of experiments is nothing but design of experiments. So we can use only limited number of experiments, not full experiments. With the limited number of experiments, we can able to get the results within the acceptable error. So that is the greatest advantage. If you take, you can see, you can take more number of parameters of more number of levels. Your number of experiments are going to increase in full factorial designs. Then the time and cost also going to increase. So once you know this kind of techniques, you can reduce the number of experiments. It leads to reduce the cost and time for the experimentation. So my talk is historical development of design of experiments, Taguchi design of experiment, phase 1 and phase 2, and ANOVA. So if time permits, I can also go through multiple linear and non-linear regression analysis. So if you look at the history of the design of experiments, whenever the scarcity is there, then you have to think alternative solutions to meet your requirements. That means you to meet your standards. Without compromising standards, you can meet certain standards with the limited number of resources. So it was started after Second World War, because in those days, many of the countries, not only Japan, many of the countries facing problems like shortage of raw material, shortage of skilled engineers, high quality manufacturing equipment. So with these limitations, we don't want to compromise the quality. Similarly, in the pandemic situation also, we are not compromising the quality of teaching. Now we are teaching in virtual mode, but we are never compromising quality of teaching. So the other side also, if you are whatever the matter is presented by this presenter or teacher, you can learn from the PPT, or you can extract some of the material from the net and you can make a notes, so that on the other side also there will not be any compromise to learning the things. Yeah. So similar way, whenever you are facing certain situations without any compromising the quality, with the limited sources, we can able to achieve a good product or good quality of the product. So what are the advantages in DOE in manufacturing process? Improved process yield and stability. So with the limited number of resources, you are getting maximum output. That yield is more. and also stability.
దీంతో మూడోది వస్తుంది.
Yes, stability is also important. So sometimes if the process is not in stable, so in one day you are getting some yield, in the some other day you are getting some other yield with the same input process parameter. So that process not comes under stability. So with the minimum variation in the output, it is always acceptable. So that process is under stable condition. And improve the process capability. You have to improve the capability of the process by taking this into consideration. Then reduce the process variability and better product performance consistency. As I said, the variability is very less. And using this, you can also reduce the manufacturing cost, reduce the process design and development time. So once you use these techniques, your process design also minimize and development time also minimized. Increased understanding the relationship between key process inputs and outputs. This is very important. So once you are giving the input to the system, then there is certain outputs. Suppose, for example, if you are using a MATLAB, you are giving input to the MATLAB software, then it will generate internally and will give the output. But what is happening inside, you don't know, unless you know the knowledge of the calculation part of the Taguchi design of experiments. So once you know that, then you can make a relation between input and output. Similarly, any manufacturing process, you take turning process. Your inputs are depth of cut and speed and feed. Your output may be metal removal rate and surface finish. By varying these three inputs, you are also getting different outputs. So once you have a set of data, input and output, then can you find the relation between these? So once you find the relation between these, let us say in earlier in basic engineering courses, we have studied linear regression, single variable, y is equal to mx plus c. That means y is the function of x. So once x is varying and y is also going to change. So if it is non-variable, that is x to the power of square or cube, like that. So depending upon your relationship, then you will also get your variation. So please mute your mic.
19 plus 5, 24.
Hello.
Sir, Ravindranath Tagore garu, please mute.
Yeah, once you understand the relation between input and output, we can also predict within the range of the output response if you are not done the experiment also.
70 plus.
Suppose x is varying from 10 to 50. You know the value of 10 and you know the value of 15, but in between, if you want to know, then you should know the relation between y and your input. Then increase the business profitability by reducing scrap rate and defect rate, rework and retest. So this also, by optimizing the process parameter, then you can also see that scrap is very low and defect also you are minimizing.
Yeah, sure.
So based on this, the task is given to Taguchi. Through his research, develop the foundations of robust design. Robust design draws on many ideas from statistical experimental design to plan experiments for obtaining dependable information about the variable involved in making engineering decisions. So once you are done ANOVA analysis after receiving the data from these set of experiments, you do the ANOVA analysis, then you should know the information about the process on the response. Then you take the engineering decision whether the process is correct or not. If it is not correct, how you are making the correctness of the process by incorporating certain variables. Sometimes, for example, we have noticed during ADM process, sometimes voltage is not affecting directly onto the machining of any material using ADM process, but indirectly it helps to improve the process. That is interaction with another variable that will enhance the performance of the process. So in statistical experimentation, only you can see the effect of voltage on the performance. Then immediately the person should say that there will not be much effect, only 18 to 20 volts is enough. So even 18 or 20, there is no much difference on the performance. But as a engineer, we can say in depth of the process, then you should say that. So it may not affect the individually. It may affect the combining effect onto the performance. So as I said, it can be applied to wide variety of problems. Robust design is still, you can also make your own designs based on your experimental data. You can make some designs. We are getting some designs also out of Taguchi designs. Our one of the professor Nilakanteshwara also has done separate designs from the statistical experimentation based on the work performed by the MTech and PhD scholars also. A Taguchi design of experiment. Taguchi method is primarily a research and development for experimentally improving the quality and for making the product robust against noise. Yeah, what is noise? So if you are performing any machining operation using a lathe, you are giving inputs, speed, feed, and depth of cut. You are measuring the metal remove rate, for example. If you are go on running the machine after certain time, your performance is also going to change. This is due to temperature or environmental conditions or tool worn out. So this we should know what are the noise factors which involves or which affect the performance. So those noise factors we cannot control. The parameters which are not controlled by you, those parameters we can call it as noise factors. So noise is intentionally included in Taguchi design of experiments. So that's why the variation from the real one and the experimental one or theoretical one, the minimum error you are going to get. So this is the beauty of the system. Any other tools we cannot use noise factors. So in the formula we can included theoretically noise factors based on the conditions available. So those things we can predict the performance without much deviation. So this is done by conducting matrix experiment in which several control parameters are weighted in balanced manner and noise is intentionally included during experimentation. So we are intentionally added because every process has its own noise. Okay, don't take another way because during my presentation, some faculty member is without mute the mic, he can speak to some other else. So the noise is coming. Then immediately the convener has to tell to that faculty, please mute your mic. So these are the noise factors. So these noise factor disturb the system performance. So similarly, in the machining process also, or any other system, there should be a noise. You take any system, noise is there in a present system, in a system. Without noise, we cannot call it as a real system or true system. Yeah, DO is an important tool for designing process and products, a method for quantitatively identifying the right inputs and parameter level for making high quality product or service. As I said, it is family fractional factorial experimentation. Taguchi approaches the design from robust design perspective. Yeah, robust design strategies to prevent problems through optimizing product design and manufacturing process. You have to optimize the process, or you have to optimize the product design. You have to optimize the system using this tool. Yeah, there are 3 steps for achieving a robust design. One is concept design, parameter design, tolerance design. The concept design based on your knowledge, based on your experience, based on your thinking power. You want to develop a new product. That is own ideas. That is your patent work. So if the person has a vast experience, he can able to get the more number of patents because of more conceptual designs are used for making the patents. So here there is no tool, there is no Taguchi, there is no other tool. Only based on your thinking, based on your vast experience from the previous conditions, you can able to get it. Then the parameter design. You have so many parameters. For example, EDM process, you take EDM process. Pulse on time, pulse off time, and discharge current, gap voltage, flushing pressure. Then stirrer, if you are using stirrer, that stirrer speed, that is, then what is the shape of the stirrer, how much you are keeping the stirrer from the bottom of the fluid. Like so many parameters are there. So if you are including all the parameters into the system, it becomes laborious process. Then if you are considering all the parameters, then you have to think of the alternative solutions to minimize the number of experiments to achieve your goal. So here the optimization tool is used, parameter design. You can use Taguchi design of experiments. Then coming to tolerance design. So if you are any mating parts, then you should see the tolerance of the 2 mating parts. If the tolerance is okay, then its functionality is okay. Suppose if you take shaft and bearing, if you maintain the proper tolerance on the shaft as well as bearing, it is functioning. Otherwise, it may not function. In that sense, the performance is very, very poorer. So the tolerance, closed tolerance, you can do for high manufacturing process that leads to increase the cost of experimentation. So now we are concentrated on the parameter design. So this is the theory already explained. Yeah, the robust design uses 5 primary tools. Yeah, directly I'm going to the figure. Yeah. So this is the parameter diagram. Then you can see the inside the rectangular box, there is a product, process or system. On the right side, you have a signal factors and noise factors and control factors. And outside of this right side, you have response. So these are the inputs to the your system or process or product development: signal factors, control factors, noise factors. So here noise factors in this Taguchi generally added to the system. So you are giving the input to these all these things, you are getting certain output. So what is the factors? So signal factors, parameters set by the user or customer. The signal factors, parameters are set by the user. So user give some parameters to the manufacturer. So based on his requirement, we are able to produce the component or product. So those parameters are set by the user. So here, whether the factor is possible or not, he should say after analysis. So no, this parameter setting in this particular process or product, it is not possible. Suppose if it is possible, what is the range of that parameter? That also you should specify. So it is not your control, it is controlled by user. For example, you take automobile sector. Based on the user requirements, we are going to develop many models. Otherwise, one model is enough. Okay. Anyway, you are going either a good design car or moderate design car. Your destination is you have to reach from one place to the other place. So design of the car, aesthetic appearance. For that purpose, the customer or requirement. Based on that, you have to make different designs. That is comes under sheet metal forming process. Then you can able to do that. Otherwise, people will not buy old design cars. So noise factors, certain parameter temperature parameters cannot be controlled by the designer, like temperature, humidity, electromagnetic, vibration, human error. So these temperature, for example, if you are conducting tensile testing during using universal testing machine, in winter and summer, if you take summer, it is 34 degrees centigrade, for example. In winter, it is around 20 degrees centigrade. So there is change in the temperature due to the environmental conditions. So this temperature also influences your output. So if you go through the literature, what is the effect of temperature on the performance? If you see the temperature, effect of temperature, your performance is come down. Your strength is low compared to the winter one. But there should be standards, ASTM standards. As per ASTM standards, you should be conducted at 24 degrees centigrade. That's why universal testing machine are kept under controlled atmospheres. Similarly, humidity. Humidity is also one of the factor. So during welding process, this humidity plays important role. So more humidity, it leads to porosity in the welds. That's why humidity is also very, very important factor. 60% relief to humidity. Then there will not be any voids during the welding process. Then electromagnetic also there. Suppose electromagnetic is surrounding your welding process, it deflects the arc due to the magnetic field. So you are not getting the correct temperature or correct energy at the particular area where you are going to weld. So that leads to incomplete depth of the melting area. So that leads to defects in the weldments. And vibration also. Suppose in machining process, if the machine process, if the machine is old one, the stiffness is very low, then lot of vibrations will come into picture. Due to vibration sternations during machining process, the uneven surface finish is also going to occur. So these are we are not under control. So the parameters which are not controlled by, those comes under noise factor. Sometimes any two products, if you take any two products, they are not identical. So every product is unique. Every human being is unique. Even twins also, there should be some variation among those two childs. So the variation, unit to unit variation. Then control factors specified to the designer or manufacturer and cannot be changed by the customer. So I want to design a machine based on your knowledge and giving some sort of output for the machine. Then you have to design your own parameters. So you have to sell the machine. So these are the machine. These are the certain specifications. If you want, you can take this machine. Otherwise, you can go for new version, new machine. Yeah, the another factor, quality loss function. So here I am showing the two quality loss functions. The mean is the m is the targeted value. The m plus delta naught, m minus delta naught. So delta naught is the variation of the process, whether it's a plus delta naught or minus delta naught. So if you take any system, your performance either plus or minus delta naught, then you are accepting. So if you take quality loss function, it is a linear one, either delta naught or minus delta naught. Then if you come back to the non-linearity of the quality loss function, there is a non-linear, either maximize delta naught towards the right of m, towards the left of the m minus delta naught. But there should be a variation from delta naught to minus delta naught. So this is always a variation is a advantage to the designer. So here only delta naught and minus delta naught. So here there is a lot of variation because the variation due to the noise factors or control factors. So due to that, it may affect the process. So that's why always you should say non-linear variations. So non-linear variation in the process is always an advantage. Yeah. Now this is also one important information. Those who are using Taguchi methods. Signal to noise ratio consolidates several repetition, at least two data points into one value, which reflects the amount of variation present. So if the cost of the material or cost of the process is a medium, then you better to take three data points. Why we are taking three data points means, so for example, I am measuring the metal remolded in a turning process. In the same condition, I am getting 20 mm cube per minute and 21 mm cube per minute and 30 mm cube per minute. These are three data points, three observations, 20, 21, 30. Then immediately, not only you, as a layman, why it is varying so much high, 30, 20 is there, 21 is there, 30 is there. Something wrong on third experiment. While you are measuring the MRR or taking the reading value, so many parameters are involved to give the either highest value or lowest value. Suppose if it is not possible to do again, what you do is you take 20 and 21 because these two are closer. So 30 is out of your boundary anyway. So if you are conducting again, it may close to 20, 21 or 22 like that. So once you take the 3 data points, so it is very, very useful for the analysis. Suppose if you're taking 2 data points, let us say 20 and 30, which one is correct? I don't know. Maybe 20 is correct, maybe 30 is also correct. So that's why 3 data points is also required to get the your correctness of the analysis. By mistake, you are taking 30, but actually it is wrong. It leads to some other information that is leading to some other variations. So that's why 3 data points is always a better point, better way. These 3 data points, you can make it average and convert into signal to noise ratio. So what is signal to noise ratio? So earlier slide, I am showing the P diagram. It's a product, process, and system. The signal factors, control factors, noise factor. Now you should understand signal factor is decided by the user or customer, whereas control factors are decided by the manufacturer. So noise factors, anyway, it is involved in the process, you are getting output. What is the difference between these two diagrams? So here signal, there is no signal factors. So this is known as static problem. So once customer is involved, it is a dynamic system. So immediately now this dynamic system is an advantage in additive manufacturing because dynamically if the customer wants, immediately you can also implement in your software by changing according to his requirement. You change the profile. Yes, you can transfer this profile into the AM machine, convert into STL file, and again transfer to AM machine. So dynamic system is an advantage, certain processes. Whereas if you take casting process, the dynamic system is not useful because the casting, it takes a lot of time to get your final component. So if you want to change the system, then everything you are going to change. For changing itself, it takes a lot of time in a conventional manufacturing process. If you take additive manufacturing, so dynamically you are going to change without much loss of time. Yeah. So always for analysis purpose, we are always using static S/N ratio. Why we are not used this one? Because a lot of mathematics, non-linear is existing. So a lot of mathematics background is required to know the performance in a dynamic conditions. So now our restriction is to restricted to static problem, not dynamic problem. Yeah, what is normally 3 types of signal to noise ratio. One is smaller the better, larger the better, nominal the best. Smaller the better. Suppose surface roughness. Surface roughness. I'm not talking surface finish. Surface roughness. Surface roughness measured in RE. That should be always engineer look for lower. Lower the better or smaller the better. Larger the better. That is strength and efficiency of an engine. Larger the better. The nominal the best. Sometimes the customer wants, I want this particular MRR. I don't want other types of MRR. Plus or minus some deviation. In that case, you can always, the performance value. Indirectly, you can do the process. Then you can give this certain set of parameters. So the formula for minus 10 log 10 mean sum of square measured data, and larger 10 minus 10 log 10 mean sum of square of reciprocal of measured data. That is minus 10 log 10 y1 square plus y2 square by 2. Like let us say, for example, minus 10 log 10 1 by y1 square plus 1 by y2 square by 2. So this is, you have a value. From that you can get the input. Yeah. There are 8 steps involved in Taguchi method. One is identify the function, and what is the side effects and the failure mode. So what is the function you are going to optimize? That objective should be clear. Suppose as a layman, as a technician, I am giving certain input condition. He don't know. Just he has to perform the experiments and he will give the results. But as a researcher, as a engineer, you should know the whether it is a minimization function or maximization function. Then what are the side effects? Then what are the failure mode? What type of failure or their particular knowing the responses. Then identify the noise factors, testing conditions, and quality characteristics. What are the factors which are giving noise, which are giving disturbance to the system? Then what are the testing conditions, also important, and quality characteristics. Then identify the objective functions to be optimized. Then identify the control factors, working range, and their levels. This is important again. So what are the parameters are important for the process? And each parameter you have certain range. So that range given by the manufacturer. And how many levels you are going to take. That is also very, very crucial role. So once you select the orthogonal array based on the number of factors and number of levels, you are going to select orthogonal array and perform the matrix of experiments. Then conduct the matrix experiment in random order. So why we are going for random? Suppose 1 to 10 experiments are there. So you have to do it initially first experiment, then you can choose randomly 10 or 9, then again 2 or again 4 or 6 like that. So why we are going for random is to reduce the noise. That is only the purpose. Then analyze the data, predict the optimum level and performance. Perform the verification experiment. Yeah, once you are having the data, then you can analyze the data using ANOVA analysis. Then you are also supposed to get predicted value, predicted response. Then you can confirm the predicted response by conducting the experiments again with the optimum input conditions. So this is the 8 steps. Yeah. The factor 2 level, at least 2 measurements in general, 2 levels, m factors, 2 to the power of m measurements. If the factor is selected at 2 levels, more economical. If the quality character is very important, choose 3 levels, that is 3 to the power of m experiments. So as number of levels increases, the number of experiments also going to increase. So you can see in the future slides, which is more benefited for the quality. Yeah. So directly go to the next slide. Yeah. Yeah, this is, let us say, level, the range. Range A, 0 to A is a one range, 0 to B, another range, and 0 to C, third range. So I am seeing the performance, that is the effect of the variable on the performance. Suppose the variable, let us say speed, cutting speed in a machining process. I am going to see the metal removal rate. After increasing the cutting speed from from 0 to C, so I am getting the variation is like this. Okay. So then which range is better? Either C is better, or A is better, or B is better. Suppose unknowingly I am taking the C range. So if you are considering the C as a range, no doubt you are getting the maximum value here. That is better than the initial value. Okay, I am satisfied with this one. So I am getting the maximum value at the point 5. So after 2 years, somebody is claiming, no, your range is not correct. My range is better than you, right? So yes, consider the range is B. So the B range is E here. The value is here. The B value at the end of B range value gives a better value than yours. Now he is claiming your range is not optimum. My range is optimum. Even though you are getting the higher value than your initial value, but my higher value is the more than your value. Fine. So he is claiming, then he is verified with various experiments, number of experiments. Finally, he is claiming that your value is not correct. Your range is not correct. So I should say, so after some time, somebody also working the same area, he has taken this particular range up to this point. Up to this point. Now he is claiming, no, your both the values are lower than my value. So I am the highest one. So this we can call it as local maximum and global maximum. Yeah. So these are the local maximum points, local maximum points, but there is a global maximum. Suppose if you are taking this as a range, this as a range, even you are applying any algorithm to this particular range, you are getting the maximum values here only, not here. But I am taking, now I am claiming again, even though my range is very high, but I am getting global maxima, but you are not getting global maxima. With the use of some optimization techniques, I am getting the maximum value. So the particular range is required. So whatever the equation you are developing, that is valid for from here to here, this type of range. Whereas this B range, this is valid for only up to this point, not this point. Understand? So using Taguchi, he can claim that B is better than C, but I am claiming other way using optimization techniques. My results, my analysis is much better than yours. So this is ultimate. That is ultimate my maximum point. If anyone is going to do, then you are reaching this the same value. So nobody else is claiming my value is better than you. So that's why. So I am suggesting you take a wide range and you can see the effect of the variable on the performance. Suppose if it is successful to get the performance, so even increase, somebody is getting down, why not increase further? Suppose if I increase some further, if it is not possible to get the, let us say, EDM process, the burning may take place. So due to burning, you are not able to correct machining. So you have to stop here. Then you have to give the explanation for this. So up to this let us say discharge current on MRR, we'll stop it here. Beyond that, it is not possible due to burning of the material takes place because of the high current. So once you know the logics of the stopping or extending the ranges, then you will be the good researcher. So with this, you can get a basic paper of your research work. Effect of each and every variable on the performance, and see the what is the maximum range, why we are not extending, what are the reasons for not to extend, and why you are stopping the at a lower level. Suppose somebody is also asking, why not starting from lesser than this value? Okay, fine. So if you are applying, the machining could not be taking place because sufficient energy is not available. If the energy is not available, your metal is not removed during the machining process. So you can give the proper justification for the range of lower limit as well as higher limit of the variable. So you can also give the evidence with using some other analysis. If you go for some microstructure analysis and other destructive analysis, then you can fix the particular range. So this is now economical range. If you want to see the global optimization, this is my economical range. So if you are not looking for global one, so this is your economical range. So the factors effects means effect of the mean only, effect of the variance, effect of mean and variance, effect of neither. So just you can see the shifting of the diagram from the mean, that is 0. This is effect of mean shifting. This effect of variance. So both are shifting, effect of mean and variance, and no effect of either mean or variance. Yeah. So this is one example. This is one of my research scholar has done during EDM process. He has to fix the range of the powder concentration during EDM process. So with this one graph, I'll make it a paper. How? Just you can listen. So I'm adding powder concentration. So first of all, why you are adding powder concentration? So if you are adding powder concentration, the electrical discharge is increasing due to the increasing the number of sparks. So your energy is distributed to the powder particles, and the powder particles also energized and giving a spark. So if you are increasing the powder concentration, more number of sparks are generated. If the more number of sparks, then your metal removality is increasing. So that's why the metal removality is increasing in the blue color. After certain powder concentration, it is again decreasing. So this is due to if you are adding more amount of powder to the oil or EDM oil, agglomeration takes place. Due to agglomeration, this energy is not effectively transferred to the each and every powder particle. So that's why the spark intensity is very low or reduced. So that's why the metal removality is decreased. And in other way, this red line, average surface roughness. So normally in conventional machining process, you take any conventional machining process, metal removality is increasing, decrease the surface finish or increase the surface roughness. Understood? So if you are going for unconventional machining process, this is somewhat different mechanism. So here metal removality is increasing, the surface finish also improving. That means surface roughness is decreasing. So it is very advantage to the manufacturer. Both performance characteristics is improved. So why it is decreasing? Then you see the mechanism. You can go to the literature. So if you are adding powder, the energy is transferred to the powder particle. The powder particle also energized and giving a spark of diameter is lesser than the without powder concentration. If the diameter is very, very low compared to the without powder, the spark diameter is, then metal removality is increasing as well as surface roughness. That is, RE is average value, means of peaks and value. So if the depth of the crater or diameter of the crater is low when the powder is added, then surface roughness is decreasing up to certain level, and beyond that it is increasing. So this is due to, again, agglomeration of the powder particle. Due to agglomeration, the spark diameter is much higher than the previous case, then the surface roughness is again increasing. Now my objective is maximization of MRR and the minimization of surface roughness. Now I can give the range up to 5 grams. Fine. So if you are doing in this manner, you are able to get this kind of conclusions. Okay, somebody has also doing the experiments without doing the prior experiment. He has to take 0 to 20, no doubt. You can take, no problem. If you have full of money, you can take. If you have a lot of time to conduct the experiments, you can take. Now, unknowingly, I am taking 0 without powder and 10 and 20. Fine. So with this range, maximum range, I am performing the experimentation. Then once I take it 10, your value is here. Even if it 20 also value is here. There is no much difference between 10 and 20. Whereas some difference between 0 to 10. Then you have to go back to add 5 grams per liter. Then you are getting this one. So instead of doing the back calculations, and you can also increase the cost of experimentation. Why? Because you are adding the powder concentration into the dielectric fluid, that is 10 grams per liter, 20 grams per liter. If the cost of the powder is very high, unnecessary you are spending much more time on the doing experimentation and on the cost of the purchasing the powder particles. So that's why initially every researcher has to do this kind of preliminary experimentation. So with the preliminary experimentation, you should know the reasons for decreasing or increasing the performance with the effect of the particular variable. And if you are not the reasons at the junction, then you can do some other analysis. Suppose you take the microstructure of the sample at this condition and at this condition. Under SEM, you can observe the depth of the crater is low here. Here depth of the crater is high. So by taking the SEM pictures, you can able to understand, oh, if you are adding the powder is lesser than the 5 grams per liter, the depth of the crater is low. That's why the surface roughness is lower. Like that, you can do the analysis of each and every stage. So that you can make a paper. Yeah, once you know the range and how many parameters like this. So based on the degrees of freedom of parameters, number of levels -1, then degrees of freedom of interaction A cross B to be calculated like this: level of A, number of levels of A -1, number of levels of B -1. Yeah. Then in the first starting, I should say that individually may not be influencing, but combining with other parameter may influence the parameter. How should I know? Interaction between A and B. A is the separate parameter, B is another parameter. How should I know whether the interaction between A and B? Just I am giving one example, which is related to the casting experimentation. So A is the percentage of copper content and B is the percentage of magnesium content. So A1 is let us say 3.5, A2 is 4.5, B1 is 1.2, B2 is 1.8. So with the permutation combinations, I am supposed to get A1 B1, A1 B2, A2 B1, and A2 B2. So just you can represent in the here, A here and B here, A1 B1, A1 B2, A2 B1, A2 B2. So after taking this combination, then I do casting by varying the copper as well as magnesium in a particular condition. Then I do casting. Then after completion of the casting process, then I have to measure the hardness of the cast components. Then the measured hardness values here 76 and 78, that is A1 B1 condition. I measured hardness of two different samples. Then those two different samples 76 and 78. Here 77, 78, 73, 74, 79, 80. Yeah. So with this, I can draw the graph like this. So Y is the hardness and A is the percentage of copper content. So if I know the A1, B1 hardness value at the particular here, then A2, B1 is here. Just draw the line. Yeah. A1, B1 hardness value average and A2, B1 hardness average value. Similarly, A1, B2 average and A2, B2 average. So once you join these data points with the respective line, then you can observe this, there should be a non-parallelism. So if it is non-parallelism, there should be interaction between A and B. Suppose the line is similar to this, that is parallel to this one, there will not be any interaction. So by knowing this, A to B1, A, B interaction is there. So like that, you can also estimate the interaction effect of other parameters. Then you should come to a conclusion that yeah, I'll tell you afterwards. Okay. Yeah, why we are doing, once you know the interaction between A and B, like that, you should know interaction between other parameters. Before selecting an orthogonal array, you should know that how many parameters are involved, how many interactions are involved, then how many, based on that, you should select a orthogonal array. Suppose, for example, without my prior knowledge, directly I'm selecting L9, let us say L9. So once you know the L9 of orthogonal array, just you can blindly are conducting experiments and getting the results, and you can analyze. Then one day you may get a doubt. Sir, if I consider interaction between A and B, not possible, because L9 is doesn't have any interactions. So unnecessary, without knowing the prior knowledge of the layout using for your experimentation, you are held up without interactions. But in the real systems, there should be interaction. Then whatever the experimentation you have done is going to be waste. Whatever the money you are spending, whatever the time you are spending is wasted. That's why before using you should know the layout, its feasibility, its working range, its limits and merits and demerits. Yeah. Yeah, based on the selected levels of the process parameters and their interactions, you can also select orthogonal array. Suppose number 2 levels parameters 2 to 3, L4, 4 to 7, L8, 8 to 11, L12, 12 to 15, L6. These layouts are designed by Taguchi. So what it means, L8, I'll come to the next slide. Suppose if it 3 levels, 2 to the power of 4, 9 exponent. If 2 parameters are formatted, are 3 parameters, you can use minimum layout in 3 levels is L9. Here minimum level in 2 levels is L4. Similarly, if you are using 5 to 7, L18. What is L? What is 18? What is 9 means? So this is standard notation using orthogonal array. Ln x to the power of 5. L is Latin square. N is the number of rows or number of exponents. So here I am telling L9 means 9 exponents. L18 means 18 exponents. So what is X? X is the number of levels and Y number of columns. So number of levels, Y is the number of columns are equivalent to the number of parameters. Yeah. Yeah. If it is 4 factors, let us say at 3 levels, number of exponents 3 to the power of 4, 81. That is full factorial design. Whereas Taguchi, 4 factors at 3 levels, L9, 3 to the power of 4, 9 exponents. See how many exponents are reduced using Taguchi designs. You are using the same parameters and same levels, but number of exponents is, here is 9, here 71, 81. So 72 experiments are minimized using this method. Then you are going to do not only one experiment, you have to do at least 3 sets of data, 81 into 3, 243. Here 9 into 3, 27 experiments. How many experiments are reduced? How much material is you are saved? So cost is also reduced. Similarly, 2 to the power of 7, 128 experiments in statistical experimentation, whereas here you have only 8 experiments. So once you know the layout based on the number of parameters and levels and interactions, then you can perform the experiments in a random order. Then linear graphs, yeah, directly I'm going to, yeah. So this is a linear graph. This also given by Taguchi. So every layout, maybe one or more than one layouts, linear graphs are available. So for example, I am showing L8 to the power of 7, 2 linear graphs. What is the difference between these? So there are here 1, 2, 3, 4 node points. Dot points indicates nodes. Node means nothing but parameter. The first parameter, second parameter, third parameter, and fourth parameter. So here also 1, 2, 4, 6, 4 parameters. Now if I connecting the line between the two dots, that should be interaction. So whether interaction between 1 and 2 is there, then I should draw a thick line like that. Suppose A, B, C, D. 4 parameters. So interaction between A and B is existing, A and C is existing, and B and C is existing, and D is not having any interaction of any other variables. So here D is alone in this linear graph. Whereas if you come to here, A, B, C, D. So A is interacting with the B and also interacting with the C and also interacting with the D. See the difference. So once you have a 4 parameters, let us say, somebody wishes to have know the interaction between A and B and C, A and D. If interaction is existing based on the prior experimentation, then you should consider this type of linear graph. Suppose D is not there, D is not having any interaction, A and B is there, A and C is there, B and C also there. Suppose B and C is not there, you don't mind. You should consider only this, because for this layout, these are the two linear graphs are available. So why we are so insisting on the linear graph? Because if you are taking this linear graph, your layout is different. For this, your layout is different. So by knowingly, you should consider which layout belongs to your layout. For example, so A cross B, C, A cross C, A, B cross C, D. Now, what do you understand by taking this as a layout represents for which first one linear graph or second linear graph? So obviously, it is a first linear graph, because A cross B is there. A cross B is there, A cross C is there, B cross C is there, D is alone. So now you are considering this layout. Now, so during my PhD work, I am struggling a lot to know these things. So A cross B, A cross C, B cross C. Now, the major doubt, how do you include during experimentation? How do you conduct the experimentation? Suppose A is there, B is there, C is there, D is there, but A cross B is not feasible now. So during experimentation, A cross B, A cross C, A cross B cross C is not required. Only you have to consider A, B, C, and D. So once you know the particular, let us say 6th experiment, I want to perform 6th experiment. For that, A is at 2 level, B is at 1 level, and C is 2 level, and D is at 1 level. Then if I know the conditions of the particular number, then I can perform the experiment. If I know all the experimental response values, then I can do the analysis. So during analysis uh, process, you are taking A cross B and A cross C, A cross B cross C. So from the analysis only, you should come to know that whether what is the amount of effect on the performance by A cross B or A cross C or B cross C or individual. So this is the logic. Yeah. This example will give you an idea how do you calculate the degrees of freedom of the particular layout. For example, so an experimenter wishes to study 1 2 level factor and 6 3 level factor. What is a suitable orthogonal array? So one factor is at 2 levels. Degrees of freedom is, this is a formula. Number of levels of factor is 2 minus 1, 1. And 6 factors, 3. Degrees of freedom, number of factors into 6 into 2, 12. The total degrees of freedom, that is 1 at 2 levels, that is 6 at 3 levels, 1 plus 2, 13. Total degrees of freedom of the particular condition is 30. Then from the standard table, you select the orthogonal array which is having or at least the degrees of freedom, the selected experimentation. So here 13, here you are taking L8 2 to the power of 1 and 3 to the power. So degrees of freedom of the layout is 18 minus 1, 17. The 17 is higher than this one. So once you know the degrees of freedom, then you can choose the proper orthogonal array. That orthogonal array should be having the degrees of freedom which is equal to this degrees of freedom or higher than this. Yeah, here some situations only two levels are available. For example, uh, positive and negative polarity. For example, I am considering the polarity is also one of the factor during EDM process, positive and negative polarity, only two factors, not more than two. But some other factors you have more than two. So that's why, so this type of layout can be used in some cases. Then analyze the data, predict the optimum level and performance. So once you have the data, then you can go for ANOVA analysis. So ANOVA is statistically based decision tool for detecting any differences in average performance of groups of items tested. The decision rather than using pure judgment takes variation into account. So here, no way ANOVA, one way ANOVA, two way ANOVA, three way ANOVA, like that ANOVA also available. No way is not available. One way is one variable, only one variable. What is the effect of one variable on the performance? Two way means two variables or interaction A and B also should be considered. Then three way is A cross B, B cross C, A cross C, or A cross B cross C. Three variables. Yeah. So another important one is F ratio, statistical F ratio, Fisher's ratio should be calculated like this. F ratio, sum of square due to y1 by sum of square due to y2. And also you should see the F ratio from the table. This is to be calculated from the analysis, and also should see the at 95% confidence level. That is F alpha, degree V1 and V2. So V alpha is the risk, and confidence is 1 minus risk, and V1 is degrees of freedom of Y1 and degrees of freedom of Y2. So 95% confidence means 5% is defective. So for that, what alpha you should know, that is 1 minus 0.95, that is confidence level, and alpha is 0.05. So then degrees of freedom of y1 and the degrees of freedom of y2. You should also know the what is the degrees of freedom of y1. From that, you should know the value from the Fisher's table. Then, if the F ratio is greater than the tabulated value, that is whatever the value are calculated from the analysis, that F ratio is greater than the tabulated value, the parameter is more significant, otherwise insignificant. So from the F ratio, you should identify that this particular parameter is insignificant or not significant. And also you should calculate what is the percent of contribution on the performance by each parameter. So once you know the optimum condition, then you have to confirm the confirmation test, verification of estimates as two steps. Prediction must agree under the laboratory condition, actual manufacturing conditions. So once I go to this case studies, you can understand very well about the process. Yeah. Yeah, you take any process. Here I'm taking EDM process, electrical discharge machining process. Number one, identification of the process parameters. Sorry, discharge current, pulse out time, and pulse out time. So these are the parameters. Interestingly, which affects the performance. Yeah, sorry, I'm getting cold. Yeah. Next, level of the process parameters. The identification of range of process parameters. Here, 3 levels are considered. Yeah, the discharge current, pulse on time, pulse off time. So this is my range 10 to 20, and pulse on time also 10 to 20 microseconds, and pulse off time, these are positions 7 to 9. So each position corresponding to certain microseconds. Then I should give the justification why not taken less than 10. So the machining could not be taking place. Above 20, why not consider above 20? Because the maximum value in our machine is 20 amperes, 20 micro amperes. So with this justification, I can able to do the further analysis. So here the number of process parameters is 3. Yeah, 3 parameters: discharge current, pulse on time, pulse off time, and level of each parameter also 3, because I have considered 3 levels: 10, 15, 20 per discharge current. The degrees of freedom is 3 into 3 minus 1, that is 6. Because in as I said, L9 we don't have any interaction. I don't want interaction because in preliminary experimentation I'm not having any interaction between parameters, so I'm not considered. So for that I have chosen L9. Otherwise, if interaction is there, then you can switch over to L27. The total degrees of freedom of individuals, that is 6. The degrees of freedom for the selected orthogonal array should be greater than or equal to the degrees of freedom of all the parameters and their interactions. So L9 is suitable. So its degrees of freedom is 9 minus 1 is 8. So 8 is greater than the degrees of freedom. So I am satisfying the conditions which are laid by the Taguchi. So I'm perfectly suitable for L9 3 to the power of 4. Now, this is the layout. These are the standard layouts. We cannot fix anything. This is a standard. So 1 means 10, and 2 means 15, and 3 means 15, like that. So in the layouts, they are given numerical values like 1, 2, 3. Based on your testing condition, you have to change. Yeah. So once you have this one, then I am perform the experiment in 2 set of experiments. So these are the MRR, trial 1, trial 2, 6.06 and 6.1221. So like that I am getting. Now I am converting to signal to noise. Now here noise is included. In Taguchi, noise is included by converting these 2 values into signal to noise. How you are converting? Yeah, conversion is like this: 1 by this is maximum span ratio minus 10 log 10 1 by 6.60 square plus 1 by 6.122 square divided by 2 will give this value. So once you have the signal to noise ratio for all L9, then you can do for NO analysis. First you can go with the average value, that is sigma y by n average, calculate sum of square due to mean n into y bar square. Then there is a correction factor sigma y square by n. These are the simple mathematics. Using this formula, you can able to solve easily. Sum of square due to mean, like this. Like this, you can also separate because it is every layout is orthogonal nature. You can separate to level 1, level 2, level 3. A at level 1, y1 plus y2 plus y3 by 3. Why I am taking is just to go back to the table. Yeah. So suppose I want to A at level 1. A at level 1 is 1, 2, 3. So average of 1, 2, 3 will get the A at level 1. A at level 2, 4, 5, 6. Average of 4 and 5, 6. Then A3. Suppose, for example, let us say A1, sorry, B1. B is the pulsar time. B1 is the level of A1, level of A1, level of B, sorry, level of B is 1. Then this first experiment, fourth experiment, and seventh experiment. Corresponding the values, this plus this plus this total by 3 will give the B1. Similarly, B2, 2, second experiment, and fifth experiment, eighth experiment. Like that, we can separate into this fashion and tabulate it like this. So once you the factor A, B, C and level 1, level 2, level 3. So factor A of level 1, this value, factor B at level 1 of this value, factor C at level. So once you observe this one, the maximization problem. My MRR is a maximization. So wherever the maximum of value of the particular level, that you should consider. So for example, if you take factor A, the maximum value at 3 level, that is 23.53. Maximum at factor B, 24.27. And maximum at factor C, 22.25. So if I take A3, that A level at 3, B level at 3, and C at level 1, that A3, B3, C1 is the your optimum condition. So by looking this table, you can see that so A3, B3, C1 is the optimum condition. So because signal to noise ratio is higher at these levels. So like that, the sum of square due to A should be calculated like this, and calculated sum of square due to error and mean square like that. Then F ratio means sum of square due to A by sum of square due to error. You should also calculate it. Then optimum condition A3, B3, C1. Then once you know the optimum condition, you should calculate what is the optimum value. A3 bar plus B3 bar plus C1 bar minus 2 into Y bar. So this 2 means, suppose we are considering 3 factors, 3 minus 1. Suppose we are not considering C1, A3, B3 minus Y bar, that's all. That is 2 minus 1. Always 1 minus of the total value number. So from this, you are supposed to get 26.0557. Now A3, B3, C1. Suppose A3, B3, C1 is available or not, just you can check by seeing the table. Yeah. So 26 is your signal to noise ratio maximum. So A3 20 is there, B3 20 is there, C1 is not there, C2 is there. So A3, B3, C1 will give the better value. So you are taking only 9 value using Taguchi. Your optimum condition is 2027. 2027 is not here. But in total full factorial designs, how many experiments? 3 to the power of 4. Total, that is 81 experiment. Yeah, total 81 experimental conditions are available. In the 81 conditions, one of the experiment is 2027. One of the condition is 2027. That will give the 26.9. Here you can understand. So once you perform the 27 experiments, sorry, 81 experiments using statistical experimentation, you are supposed to identify the maximum value among the all the conditions. So the maximum condition is 2027, but without doing all the conditions, only you are doing certain 9 conditions, but you are getting the optimum condition. That optimum condition is one of the experiment condition in 81 of total full factorial experimentation. So So this is the advantage using Taguchi designs. Yeah. Now again you have to confirm the experiment by doing experimentation, because it is not available in the layout. Again you have to perform A3, B3, C1, that is 20, 27. Then you can perform the experimentation. That experimentation value is 25.35 and the error is should be 2.75. So error should be always less than 5%. Less than 5% is advisable. If it is more than 5%, so you are doing something wrong, something calculation, some experimentation error, some parameter which are not mostly influenced by the performance, you are not considered. So many indications it may give. And also you should calculate the F ratios and percentage contribution and tabulate it like this. So F ratio is 279.487, this one 4.7. So your F ratio from the tabular column at 95%, 4 points, no, yeah, 90. So this F ratio is 90. So if the tabulated value is 19, your calculated value is more than 19. So those parameters are significant. That is, this value is A and B is more than 90. So these two are more significant. Whereas 4.717 is insignificant. Yeah. Now highest F ratio, highest more influence. Suppose 704 highest compared to the A, it is more contribution. So B is the pulse on time is more contribution. Now coming to the 4.717, so it is insignificant means what? So 4.717, because the range what you are considering is 7, 8, 9. The C range is, yeah, 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 C range is 7 and 8 and 9. Yeah. So C is 27, 8, 9. So C is insignificant means whatever you are taken the value, either 7 or 8 or 9, there is no much difference. So insignificant means that is understand by this analysis, whether you are considering 7 or 8 or 9, there is no much deviation of the performance. Understood? Now what you do is next further experimentation, you are fixing the C value either 7 or 8, 9 and varying the adding another parameter into the system, then you can do the same process. Suppose instead of C, that is pulse of time, I am keeping the constant 7 or 8 or 9, then I am adding here powder concentration, so that I can use for same orthogonal array for even other parameters included also. Yeah. So with this, what are the advantages? Advantages, you should know so many advantages. What are the limitations? Advantage already we have gone through. And then what are the limitations of the process? Taguchi design. The limitation is in the sense it gives the optimum value at the levels only. So you are taking the range that is 10 to 20, 10, 15, 20. You are considering the level of the each parameters. Level 1 is 10, level 2 is 15, level 3 is 20. You are getting the optimum condition A3, B3, C1. That is only at nodal points. Your optimum values either may be maximum or minimum. You are getting the nodal point. That means I am showing this here, A1, A2. Whether you are getting the A1 here or A2 here. But I don't know in between A1 and A2. what is happening. Sometimes it should not be like this. It should be like this also. It should be like this also. Maybe in between the A1 and A2, maybe you are getting global maximum or global minimum. So in order to get the values in between, develop mathematical model and apply any optimization techniques. Okay, I think other speakers can speak on the how to develop the mathematical models. So once you know the range of a particular variable, then you can able to generate the regression equations. Then you can apply the optimization techniques to the regression equation so that you can get the. So here I am showing for LA 2 to the power 7 the regression equation B0, B1, X1, B2, X2, B3, X3, B4, X4, B1, 2, X1, X2, B1, 3, X1, X3, B2, 3, X2. So like that, you can calculate the regression coefficients B1, 2, B2, B2, 3 using these formulas. Okay. So once you know the these values, just you can put it into the equation. Then you can calculate what is R squared, what is adjust R squared using these formulas. So these two R square and adjust R square should be closer, then only your equation is significant. Yeah. So with this, I can conclude my topic. Now it is open for discussion.
Thank you, sir. Now, anyone has any queries on the topic discussed, please, it's open for queries. You can unmute and you can say, sir.
Yes, sir. This is Wasim Ahmad.
Yeah, tell me.
Yes, sir.
Thank you for wonderful presentation with your patient explanation. So I have one doubt on this effect of mean and variance slide. The graphs what you have shown.
Yeah.
So could you please revisit that slide and explain what is that mean and variance effect?
Yeah.
Yes.
So I think you know the mean formula, sum of the numbers by number of values, total sum by number.
Yes.
So sometimes the mean also affecting. Mean this curve is mean affecting. The variation is x1 minus x bar square plus x2 minus x bar square, that variation formula.
Yeah.
So sometimes the variation during the products also it is going to vary.
Okay.
So sometimes combine mean and effect variance also affecting.
Okay.
Sometimes neither mean nor affect the variance of the system.
Yeah.
Yeah.
Okay. So, thank you. And lastly, I have one more doubt with the term called confidence level.
Yeah, confidence level, just you can go through any statistical textbooks.
Okay.
So 95 confidence level
Only
means 95% is of the products are defect free.
Okay.
So 5% component is defects.
Right.
So every system is not 100%. If the quality is more important, you can go for 99% confidence level. That
Sure.
means you are expecting only out of 100, you are expecting one component should be defective.
Yes, sir.
Yeah, 95 confidence level means the 5% defective.
Sure, sir. Right.
Yeah,
Thank
risk is 5%. That is
you.
alpha. Alpha is risk. That is 0.05, comma degrees of freedom of 1, degrees of freedom of another variable, you can get some value from the table.
Yeah.
So that is F ratio.
Sure.
Yeah.
Thank you.
Yeah, okay.
Thank you, sir. Any other?
Sir, good morning, sir.
Yeah, good morning.
Sir, what is correction factor, sir? Do we have any range for that?
Oh, correction factor normally, yes, you can. Yeah, correction factor using this formula only, sigma y square by n.
Okay, sir.
There is no range. Based on your values only, you are getting sigma this year formula. Are you able to see sigma y square by n? That is a
Yes, sir.
correction factor. Sigma y bar square.
Okay, sir. Yes, sir.
Sir, another question by Bibin. He is saying Taguchi is not recommended nowadays. What is the reason behind that?
If you are having more number of experiments, then it is useful. But if you are not knowing, if you are not giving any proper reasons after using the Taguchi method into the paper, then people are refused to accept your paper.
Yes, sir. And probably the interactions, if they have to select the column properly, and if they are not doing it that way, then the main effects are getting compromised. Maybe that is another reason. Yes, sir.
Yeah. And once you use the this kind of techniques, and you can also give the proper reasons for the statements why you are taken the particular value at the lower level 1
Yes,
and
sir.
higher level 2, then
Yes, sir. True, sir.
Hello,
Any
sir.
other question? Yeah.
Hello, sir.
yeah.
Yes, you are audible.
Sir, how to select this lower and middle and higher value, sir? I am basically beginning. I am at zero level. That's what I am asking this question.
So just I am showing the graph.
Oh.
Yeah, are you able to see this graph?
Yes, sir.
Yeah. So here the powder concentration is varying.
Okay,
MRR is or surface roughness on the y-axis.
Okay, okay, sir.
If I increase the powder concentration, what is my performance is go on increasing to certain level and decreasing.
Okay, 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 sir.
Same thing, surface roughness also decreasing to certain level and decreasing. So here I am rounded off.
Okay, okay, sir.
So this from 0 to here, my range.
Okay, sir.
For MRR, powder concentration. Similarly, for SR also, I am extending to little more than that. So compromising in both the cases, then I am limited to 5 grams or in between 0 to 10 grams per liter. So without doing preliminary experimentation, you should not identify the range. First, range is important.
Yes, sir. Yes, sir.
Once you identify the range, then you select the level. Here, level 1, level 2, level 3, for example.
Okay, okay, sir.
Level 1, let us say 0. Level 2 is 2.5. Level 3 is 5 grams.
Okay, sir. Okay, sir. Thank you.
Understood now? Why I am
Yes.
not taking 10? Because 10 is out of range.
Yes, sir.
Out of my expectation.
Okay, okay, sir. Initially, we need to conduct some experiment to find out the range and level. Yes, sir.
Yeah, range and automatically you are fixing the levels.
Yes, sir.
So normally 3 levels is preferred. 3 levels is non-linear.
Okay, sir.
So 2 levels is only linear level.
Okay, sir. Thank you very much, sir. Thank you for clearing this.
Right.
Yes. Sir, any other? Okay.
Yeah, one more information.
Sir.
Suppose if you wish to optimize the process, entire process, somebody raised the Taguchi is nowadays not useful for this. No, it is useful, because
Yes,
what
sir.
I am saying is, suppose if you are using L line, from the L line you are generating the equation. That equation you can optimize you can apply any optimization technique so that you can get the beautiful results. So once you get the equation, then you need to conduct more number of experiments if you are not using Taguchi method.
Yes, sir.
So a lot of data is required to generate that equation using statistical methods. Whereas using Taguchi, directly you are getting into equation without compromising the quality. Yeah.
Yes, sir. And I personally like this feasibility of levels, sir, in factorial design. There, like you have rightly mentioned, sir, many will argue on the ranges that we select. So it explains very nicely what happens if we limit from 0 to A and 0 to B, 0 to C. So depending upon the availability, some may select. But yes, right, sir. And that's where many of the papers, when we are addressing the reviewer comments and all, this is where we normally face the problem. And it was explained very clearly with that one example. It serves all the issues. Yes, sir. True, sir.
Yeah.
Yes. And I think many of these introductory concepts are being covered, and the details will be dealt by the individual resource persons like you have mentioned. And I think today also we have planned this design of expert software walkthrough, sir, wherein we'll try to first make them understand how these things are to be set in the given software package, whether that is a design expert or Minitab. And in fact, even in Excel, we can do some of these things. Yes, sir. So they'll have a little idea. And with that inputs that you have introduced, like the factors, levels, range, and responses, they'll try to carry out one small experiment. And with that, they will be able to go for the ANOVA and then even regression equations and even optimization if possible, sir. So that's what we are planning.
Before going to the software, ask them to do it in manually.
Sure, sir.
By taking one example, and you can do calculations with using formulas.
Yes, sir.
Then that put it into Excel sheet. Then it automatically understand by each and every resource person.
True, sir. So if anyone has any more queries, you can ask. Otherwise, we'll end the session. And the feedback link is already shared in the chat window. You can fill that feedback form. Okay. Now it comes to the end of the session, day one, forenoon morning session. Thank you, sir. Thank you for giving us the walkthrough of the entire design of experiment process. And the main important thing is the importance of this carrying out the design of experiments. Like you have rightly pointed out, many of them, they do several number of experiments and finally they say this is the main influencing factor. But in fact, they have conducted the entire full range of experimentation with which they can do much deeper data analysis, like the interaction effects and then the quality of the regression equation that they can form, and then they can even use that as a objective function for carrying out several optimization techniques also. But not knowing the importance of the quantum of data that they have, they will only limit to few necessaries of their study. So the importance is rightly quoted in this particular session, and also with very good case studies. Of course, it's a EDM, so many of the mechanical faculty have registered. They can relate that, and metal removal rate, which is very common example which we give. Yes, sir. So I would again, on the behalf of BVRIT, I would like to thank once again for accepting this invitation and being the chief guest for the day one session, and enlightening us with your experience and giving us few case studies, especially the way it was quoted, like this one example with which we can publish a paper, right sir? This is well taken. I hope others also got the little glimpse of what is DOE and how we can utilize for publishing papers and all. Thank you again. Thank you once again. Thank you all the members. Thank you,
Hello,
sir.
sir. Hello, sir.
Yeah. Yes, yes.
Sir, can you share that PPT if that guest speaker is allows?
Sure, sir. I'll ask Kumar, sir. And
You can share, no problem. You can share. You are
okay,
recording,
sir. I'll
no?
collect from. I have recorded, sir. I'll ask. You can mail me that PPT, sir. I'll share that to the participants.
Okay.
Sir, if
I'll mail
possible,
you.
in WhatsApp group, sir, please.
Okay, I'll do that.
Okay. Thank you very much, sir. Thank you. Because that presentation is very nice. We can work out the formulas. He has given elaborately, and it is very informative, sir. That is what we are asking.
Yeah. Thank you, Varan.
Thank you, sir.
Thank you, sir.
Yeah,
Thank you very
thank
much.
Right.
We will. Thank you, sir. We'll join for the next session in afternoon at 1:30 sharp. Please, I'll be sharing that link with you where you can download Design Expert software trial version. I'll share that link, and you can come join us with at 1:30. Okay. Thank you, sir. Thank you, everyone.
Thank you, Varan.
Thank you, sir.
Good luck. Right.
Thank you, sir.